Welcome back to part 2 of this lesson where we find the equilibrium constants from experimental concentration measurements. We ended off with the last question in this series, which reads, the reaction between CO and H2 in the previous example is carried out at a different temperature with initial concentrations of CO at 0.27 and H2 at 0.49. At equilibrium, the concentration of CH3OH is 0.11 molars. Find the equilibrium constant at this temperature. So just as before, Kc is equal to, in our case, CH3OH over CO times H2 raised to the power of 2. Now that we've written this down, I can actually go ahead and replace this with 0.11, which is given in the question. But to better organize myself, I want to create a chart showing the initial concentration, the change, and the equilibrium concentration. So I'll write down CO, 2H2, and CH3OH. This is called an ice chart, by the way. So we have I, C, E. Luckily for us, they've given us 0.11 as the equilibrium concentration for CH3OH. The initial concentration is nothing, especially at the beginning when no product is made. We do have reactants at 0.27 and 0.49. So using the formula which was derived in the previous example where C is equal to E minus I, C is equal to E minus I can go ahead and find out what C is by replacing E with 0.11 and I with minus 0. This gives us a change in concentration of 0.11. The reason why we need this is because we can compare this number to the ratios of the number of moles of these molecules found in the reactants. Here's what I mean. For every one molecule here, we have two molecules here. And since we're going from products to reactants, we actually have to negate that number. So to go from 0.11 to two molecules here, we multiply this number by 2. We end up with 0.22, and it's negative because it's in the opposite direction. Similarly, we're going from 1 to 1, so we'll have negative 0.11 in its change. And now, using this formula again, we can find the equilibrium concentrations. Here's how. So here we had C is equal to E minus I. I can change this around where I have C plus I is equal to E. Just using some simple algebra, moving this over. So I'll take the change in concentration plus 0.27. Let's go ahead and use our calculator for that. So we have negative 0.11 plus 0.27, and that gives us 0.16. Let's do the same thing here. This time we have negative 0.22 plus 0.49, and we have 0.27. That's all it is. That's all you have to do. And so we'll replace this part of our equilibrium expression with 0.16. Replace this part with 0.27. And we have 0.11 divided by the stuff at the bottom, 0.16 times 0.27 raised to the power of 2. And we get a Kc value of 9.43. 9.43 is the equilibrium value. And compare that to what we had in question 1, it was 26. And so there you have it. That is how to find equilibrium constants from experimental concentration measurements.